Okay guys, here's the second video for the week. So again, I'm going to be doing it through the way you see it to make it a little easier. So we're going to do linear inequalities here. So if you guys aren't familiar with the term inequalities, just a reminder, what it means is when we're talking about the less than or greater than sign. So if you guys still have trouble remembering the less than or greater than, just remember read it from left to right. So if you're reading this, you want to read it in the way of like, this is less than this. And the alligator's gonna eat the bigger thing. So if you're reading it again, that. So this is greater than that. The alligator is always eating it, eating the bigger thing, so it's going to eat the greater thing. So if this one's not interested in your first thing that you're talking about, then it's going to obviously want this is greater. So this is less than this. Should have put that here as well, but what can you do? I already did it. All right, so let's get into this lesson topic. All right, so starting the tutorial. Not a big fan that auto plays. Let me just make sure my reading narrative's off because I haven't used this since the last video. All right, so linear inequalities. So our objective for this is to write and graph linear inequalities with two variables. So before we were doing one variable. So for example, x is less than 2. It would look like this. We would have a 2 circle here, and we're doing less than, so all the numbers less than would go that way. Little trick here is think about this less than sign as being an arrow, as long as your variable is on the left. So your variable, your whatever letter you're talking about should be on the left. It's like an arrow pointing to wherever we're talking about. Now we're going to be talking about with two variables. I believe we start off learning with lines. So this idea that y equals mx plus b. So if we do y is less than mx plus b, we're talking about all the numbers smaller. So if we graph a line, we do all the numbers smaller, and this is actually incorrect because when you do a line that's less than, it's going to be dotted. We'll learn about that in this unit. So let's take a look. All right, so let's go. So we're going to be graphing, we're going to be learning inequalities. So let's take a look. All right, so show two equations and their graph, determine which equation goes with which graph. Okay, so this is just going to be a practice. So we're trying to see if it satisfies it. So in other words, it has to go inside this equation. So we're going to plug in our x's, and we're also going to plug in our y's. And what we're going to do here is I'm going to plug in the 2 into this equation. So 2 equals, and then I'm going to switch over here to 3, and I'm going to plug in my x, and then plus 4. So plus 4. I'm just using all kinds of different colors. I wish I can control what color I wanted, but it's a little weird. So here, and my x, I don't know why I did that. My x is going to be that -2. So I'm going to plug in this -2 here. So I end up getting, and I don't know how to do it where it becomes black. I accidentally switched over to the other screen. Still learning the tools, guys. I'm sorry. So this is -6 plus 4. Well, I would end up getting a -2 as a result, so it cannot go in this one. That doesn't mean it automatically goes into the next one. So now I'm going to be plugging in this point into this equation. So I'm going to do it as 2 equals -1/2 of my x is -2. And I'm going to do this plus 1. So this ends up being 1 plus 1, and that does equal 2. So 1 plus 1 equals 2, guys. All right, and now let's do our next one. So our next one is going to be this 4 and negative 1. So again, you're going to plug in that negative 1 in for the y. So I'm going to do negative 1 equals 2. Put a parenthesis to symbolize that you're going to plug it in there. And I just realized this is supposed to be a 1/2, not a 2. 1/2 and a 4 plus 1, and it's a negative 1/2. So half of 4 is, or in other words, 4 divided by 2, because we're going to multiply the negative 1 by the 4, is 2. But since it's negative, it's going to be negative 2 plus 1. So we get this negative 1 equals, does negative 2 plus 1 equals negative 1? Yeah, because we have 2 negatives and 1 positive. So what we're going to do here is we're going to grab this, throw it in there. Cool. And then what we're going to do, clear this out, is do this next one. So let me go into here. I am going to plug this into, I'm going to probably plug it into the first one because I plugged the last two into it. So eventually we have to get answers for that one. Hopefully, at least. Let's see here. So our y is 4 equals 3 parentheses, and our x is 0. So 0 plus 4. So again, all I'm doing is rewriting this formula with these in mind. So this gives me 4 equals 0 plus 4, and that's true. So because that's true, I'm just going to move that in there. Perfect. All right, let's try it again. Let's see if we can get 2 in a row for the first one. So I'm going to do 1 equals 3 parentheses 0 plus 4. So obviously that doesn't work. So hopefully it goes into the next one. Let's see if it goes into the next one. So 1 equals negative 1/2 of 0. Anything times 0 is 0. So we end up getting this plus 1. So that works for me. Let's grab this, put it over here. All right, I'm assuming these last two are going to work for this. Otherwise, they might. Keep in mind, guys, they might not work at all. Some of these are trick questions, unfortunately. All right, so let's take a look. All right, so so 1 equals 3 times negative 1. Again, plugging in this point, plus 4. So I end up getting negative 3 plus 4. I end up getting that positive 1. So I am going to plug that in here. Got that positive in there. Clear it out. And now I am going to do this 2 equals 3 minus 2 plus 4. So I end up getting negative 6 plus 4. That would give me negative 2. So, oh, and that was supposed to be, wait, yeah, that was supposed to be what I got. I just forgot to put the little negative sign. So this works. So 3 and 3, I figured as much, but you never know. Highlights the clicks. Hide cursor when not moved. Don't want that. I might use this tool. I'm still debating on it. Let me know if everything else is too dark to do this. But for right now, let's just focus on the regular one. Sorry, I was just messing around with that. Let's keep going. So that was just our warm up. So we're going to learn about when things satisfy. So the beauty of inequalities is you can have more that satisfy. So again, this is a review of one variable inequality that we've already talked about. So moving on to the next one. There's an option where, let's say it's y equals, y is less than. So if y is less than, we can always go less than that. Oh, and this is reminding me, guys, don't forget to grab your guided notes. These guided notes are useful because I recommend having them for the test, to be honest. That way you can plug stuff in while you're doing the work, and then you have really good notes for the test. All right, so moving on. Give me a second here. Let me go back to the tutorial. So this is just telling us that if something is less than or equal to, it's a solid line. It could be on the line. It could be anywhere below this line because it's less than. The y value could be less than. So that's why when we're doing this, we're talking about up and down because we're talking about how it's affected by the y value. Otherwise, if it was x is greater than or less than, we would be talking about left and right. But because we're talking about the y value, that's where we're going up and down versus the idea of left and right. All right, so let's start graphing some inequalities. So we're going to graph inequality the same way we did the other graph. So if this is our y-intercept, so this is our y-intercept, this is our b, and the next one, this is our m. So this again is our slope, and this our y-intercept. So in other words, we're going to start off here at 7, and then we're going to go down 3, 1, 2, 3, and over. We're going to move over 1 because of the rise over run. And then we have our 2 dots, and then we just make a straight line going down. And they're saying, does this point fall on it? So we can just plug it in to see if it falls in it. And you can see them plugging it in here. All right. And if it's not equal to, so notice how this does not have an equal sign. That's where we have our dotted line. Did we do it here? We did not. So you make a dotted line to symbolize that it is not, it can't fall in this. If it's a solid line, we're like, if it touches the line, that's cool, that's fine. But if it's dotted and it touches the line, we're not including that. We're talking about strictly. So if it's just this is strictly less than. The reason why I use the word strictly is like it's strict. We want it to be less than or equal to. It's like it can be equal, can be equal. This one is very strict. It's like nope, it has to be less than. We don't care about if it's equal or not. Go into our next one. So we're talking about the boundary. So this is where we're going to talk about the dotted lines and solid lines. Guess I got a little bit ahead of Edmentum here. So again, strict inequalities, strictly less than. Non-strict inequalities, that's that less than or equal to where it has a solid line, which is interesting because it's strict. We're going to symbolize it with a dotted line, and the non-strict, it's like solid. So by wordplay, it kind of seems a little weird. So we're going to ask which one's solid, which one's dashed. So this one would be dashed because it doesn't have an equal sign. This one does have an equal sign, so it's nice and solid. Equal sign, nice and solid. No equal sign, so dotted. So that's all we're looking for is the dotted or solid. And then this explains it right here. All right, so next one. So complete the graph. So we're looking for intercepts and the slope. So again, graph your intercept. So this is -6. And then your slope is your rise. So your rise is 2. And your run is 3. So if I'm doing rise is 2, from here I'm going to go start here. I'm going to go up 1, up 2, and then my run was 3. So I'm going to go 1, 2, 3. And that's what makes this line. And because of the fact that it is going to be have that little equal sign at the bottom. The greater than sign means we go shade up. The equal sign means it's a nice solid line. Again, I know I don't draw like right on there. It's kind of weird drawing on a tablet and then expecting it to go on the pen. I'll get used to it eventually, hopefully. So again, here we're doing it again. Their y-intercept was 3. Their slope, there's an invisible 1 there. So if there's an invisible 1 there, you can assume it is -1 over 1 because of that little negative sign. And it's going to be a dotted line, and it's greater than, so we're going to be shading up. So you're going to see them shade up right now. Alt M. I'm going to see if I can start getting used to these commands. Alt P. Alt M and Alt P. So mouse, okay. Pointers. So if you see a point that's above the line, so this one would be above the line, so it's cool. This one's below the line, so it's false. The Y doesn't fit. So they're plugging in these points, they're checking it out. They plugged in the X, they plugged in the Y. So you can do this both by looking at the graph or by plugging them in. So 0 is not greater than 3, so it doesn't work. And then here's the graph that shows Y. All right, so now let's get into this. So we can do custom equations. So let's say we want to do an inequality here, and it's not set up y equals mx plus b. Actually, anyway, you can just do custom. I really like doing this. One tool that I haven't shown you guys is over here. You can come in here and just, let me close this up. Go to these tools, go to graph, and just mess. Well, actually, I think I've shown this one in the last video, actually. So you go here, go to custom, and you can just type in your equation. So let's say they want us to type in this equation. I wonder if this works. I'm going to Control C, Control V. Looks like it worked. I don't know how picky it's going to be with the spaces, but let's see. Oh, it's actually fine. So you could just copy and paste your equation in there. So instead of having to go to Desmos, you guys can literally just go here and use their graphing tool to make it a little easier. What I recommend if you're taking a test, because they don't give you access to the graphing tool, have your tutorial open. That way you can just open up the graphing tool. All right, so let's do this. So we're going to do this. So begin the process of graphing this. So rewrite the inequality. So y by itself. I'm actually curious if it'll do this. Well, actually, no, there's no reason. You guys are smart. You guys know how to do this. So we're going to rewrite that. So first things first, we want to rewrite it. I was going to try to write under it, but that would be way too messy. So I'm going to write this as 3x minus 4y is greater than or equal to 24. So the first thing I'm going to do is I'm going to subtract this 3x from both sides. So I get negative 4y is greater than or equal to negative 3x. The reason why I put the x here is because, I did not want to do that. But the reason why I put that x there is because I want to put this in the y equals mx plus b form. Now, here's the tricky part, guys. Here's the part you guys always have to remember. Whenever you divide by a negative, all of the signs change. All signs change. You're changing everything from a positive to a negative. So, for example, this negative 4y right here, this, let me see if I can do this is going to change to a positive. And this is going to change to a positive. This will change to a negative. So that means this sign right here should probably change as well. So let's get into that. So once I do that, I get a positive y is less than, my sign is changing, and this will be 3 over 4, because it used to be a negative. Now it's a positive. And this will be negative 6, because 24 divided by 4 is 6, but a positive and a negative turn into a negative. So now what we're going to do here is we're going to find our answer. So it's a positive. So it looks like it's this one. Yep, because this is the only one with less. These two have less than, but this is a negative 3/4. Again, these negatives change. So it's going to be that one. All right, now we're going to do a graphing tool. So luckily, it's the same question. They're literally asking you the same question, so you don't have to calculate it again. So you can just take this and move it over here. So what I'm going to do is my intercept is -3. So it's -6, and I'm going to go up 3/4. So I'm going to do, and it is a solid line because it has that equal sign. So I'm going to do solid line. I'm going to start at -6. I'm going to go up 1, 2, 3, and I'm going to go over 1, 2, 3, 4. So that should be my line. So remember, the equation was y is, we're dealing with less than. Y is less than or equal to 3/4 x - 6. So that's why I started off here, went up 3/4, and I want my shaded area. So let's shade the area. Since we're doing less than, we want to shade the area above the line. So what you have to do with this tool is you have to click the line. Oops, that's not what I wanted to do. How do I undo this? Undo. Oh, there it is. There's literally an undo button. So click the line and shade upwards. I didn't know. You have to hold it. So remember, if you guys are using a touchpad mouse, click the line with one hand and then shade. I think you can even, you don't even have to necessarily do the line. I think you can literally do this. Click anywhere and drag. Nope, has to be from the line, then you shade upwards. So make sure you click the line and keep holding it and move the mouse upwards. All right, so see that? Incorrect. Oh, I'm doing less than. Oh my gosh. I said it like 5 times too. We're gonna do less than. We're gonna do less than, and they're gonna make me reset the whole thing right now. Uh, well, that's what I get for trying to speed through this. So -6, go up 3 over 1, 2, 3 over 1, 2, 3, and 4, and we're gonna shade less than. Cool. So hopefully you guys didn't submit that answer right away if you guys are watching this on YouTube and doing it at the same time. All right, so let me submit that. All right, so the next one, using your graph from part B, determine which of these 3 parts of the inequality. So what we're going to do here is, what I like to do is we can plug them in, but why don't we just go over here? So we're at -2, -8. Yep, that looks like it worked right there. -2, -8. Cool beans. All right, the next one is 2 +8. So we're at 2 positive. That's already a no. Next one is -8 and 0. So -8 and 0. That's good to go. 2 and -2. So we're going to go to 2, -2. That's right here. Not good. Does not work. 8 and 0. So if we're at 8 and 0, it's right on the line. And since it's a solid line, that means we're actually good to go. So that one's good to go. And the next one is 4, 4 and -4. So we're going to go 4, and we're going to go down to -4. And that is right in that shaded region. So that's good to go. And then just evaluate how you did. It's like, give myself a 4. I did not know how to shade at first. So just put any difficulties that you guys are having with it. All right. And forgot to submit these. What's incorrect? What? We did all of them. Come on now. All right. So let's see here. -2 and -8. -2 -8, that's fine. 2 and 8, we already know that that's not good. -8 and 0, right there. Oh, -8 and 0. That's where I messed up, guys. I did 0, -8. 2 and -2, we said that was right on the line, I believe. Oh, that one doesn't work. 8 and 0 works, and this works. So the part where I messed up, guys, is I did 0 and -8. So that should fix it. All right, let's move on. And as always, I could play this, but please watch this on your own. I don't want to sit here watching it and then you watch it on your own later. There's no need for you to watch a video inside a video. All right. So looking at this, we're going to match the lines up. So what I'm just going to do is I'm going to see, okay, I have two solid lines. So these two solid lines can only be this one. So this one has two options. It can either be this one or this one. Let's look at what we're doing. Are we shading up or down? So solid line shading down. So I know it has to be a less than sign. So by process of elimination, I know it's this one. So take advantage of those multiple choice guys. So we're at +4. The slope is 1. So we go up 1 over 1 and we're shading down. So that was the only difference, is that shading up or down. So let's take a look at this one. So our intercept is 5. They're both the same line. The only difference is, are we shading up or down? So this one's shading down, so we're going to do this one. And since this one's a dotted line, the only option is this one. I feel multiple choice when you eliminate stuff like this, like dragging the tiles, is too easy for you guys. And here's the explanations if you guys want to take a look at them. So let's move on here. So now we're going to be modeling inequalities. So kind of like doing real life scenarios. So let's take a look. Now that we've seen the solution, okay, blah, blah, blah. Let's move on. So modeling inequalities relationship. So let's see what we got here. So this is a less than sign. Click each image. Oh, this is just telling us if it's less than or greater than. I have a feeling the reason why it's less than is how much you can carry on. Elevator has like a maximum weight that it can, so it's okay to reach that. Greater than or less than, I'm guessing they're going to be spending money. They want to spend more than a certain amount of money. That's different. And greater than, well, we'll find out what these are. All right, so I don't know what the pictures had anything to do with that. Why did you guys have pictures behind those images? All right, so create a thing here. So blah, blah, blah. So this, if it's less than, it can be no more than this. So when we're reading it, this can be no more than whatever's over here. This greater than sign, it means we want more than that. So another way of saying more than that is at a minimum. I know it's very weird. Oh wait, not at a minimum. I am so sorry, guys. Exceeding. You want it to be more than that. This is going to exceed whatever's on the right side. So whatever's on the left side has to exceed that. And then less than or equal to. So you want fewer than this. Wait, we have fewer than and no more than. Fewer than. What are these words? Hold on. They have, like, I feel like there should be an at maximum here, but they're using a lot of, so less than this, so fewer than this. Okay. This is the problem with reading it from left to right instead of just reading all the answers. All right. So we want more than something. So we want something to exceed it. So at minimum, meaning whatever it is and more than that. So this is going to be and more than that. Okay, now it's starting to make sense. No more than this. No more than this. Okay, so you can have the amount. So no more than is referring to, like, you kind of have to kind of read in between the lines. So it can be like, let's say you have a budget. So your budget has to be greater than or equal to like $100. That means you can spend $100, but no more than that $100. It's phrased very weird. If you guys are having trouble with these, like you saw, I sometimes get weird, especially when there's no context to it. You might want to copy this down somewhere. I'm pretty sure this is in the guided notes. Let's take a look. Guided notes. I do recommend completing these guided notes a lot because it's probably in here. Yep, we have these keywords here. Fewer than, exceeds, all of them are right here. So definitely make sure to fill out those guided notes. All right, so let's take a look here. Let's work through an example. We combine modeling this work. So in the spring, Andrew works. He charges $20 a lawn and $25 to trim a hedge. He wants to earn at minimum this. So at minimum, so he wants this much or more. So remember that keyword there is at minimum. So more than or equal to that $600. And I have a feeling what we're going to do here is 20x, where always write this down, acknowledge your variables, define what your variables are. So x being the lawn, how many lawns we're mowing, and our y is going to be equal the hedges, how many hedges we trim. So that way we can make this equation up and we know what we're talking about here. So instead of writing 20 times hedges, a lot of words, we're just going to plug that in. And you're going to see them plug it in right now. So I'm kind of like explaining things. So you see that, oh, they're using M and T. And see how they define their variables? That way they know what they're talking about. So trimming hedges, mowing lawns. So they have this. So $20 for mowing, $25 for trimming, and at minimum. So that means he wants to earn more than that. He can earn that 600, but he wants to earn more than that. All right, let's go to the next slide. So what we're going to do here is we need to figure out what our y value is. So he decides to make it where trimming, oof, let me see if I can write sideways here, guys. Trimming. Oh, I started off so good. Trimming's here, and then mowing will be here. So that's why he's solving for t. This allows him to kind of figure it out. An interesting part, I don't see why Edmentum did it this way because they taught us how to graph the other way. The other way is to, like, let's pretend we don't have any lawns to mow, so we're only dealing with our trimming. 600 divided by 25. So let me pull out that calculator. Alt M. This. So let's do 600 divided by 25 is 24. So that's why there's a little dot right here for the 24. And let's pretend, I'm going to keep this calculator out. The next one, we're going to pretend we don't have any trimming. So we're only dealing with mowing. So that would be 600. Let me clear this. Here. That would be 600 divided by 20. We get 30. So that 30 will be right here. So that's where so this would be the 20 for the trimming with no mowing. And this one will be mowing with no trimming. And that way we could do a line there. Instead of having to do this very weird way that they did it, it is useful, but that's a good way to graph in standard form, especially when we're doing inequalities. because you can't mow negative lawns. So we kind of want to know our maximum trimming and our maximum mowing. If we know our maximum trimming and our maximum mowing without the other, so we figure out these without the other, then we can start figuring out our numbers here. All right, so let's take a look here. So which one of these works? So a good way to do this, let's kind of do it the way I said it. So I'm going to assume, oh, let's read this first. Okay, so let's see here. But she only has $10. So if she only has $10, she wants to have spend less than or equal to $10. And she's going to the market. So uh, she wants to buy, so there's carrots and there's leeks. And the leeks are $2. So the leek, so it's carrots plus $2 times leek. So I'm multiplying the price. This per, think of it as dollars per pound. And let's say she gets like a pound of carrots. Well, these pounds will cancel out and it's just dollars. So that's how I know I'm multiplying. So in other words, it's going to be $1 per pound of carrots plus $2 per pound of leeks. Has to be less than or equal to $10. She can't spend money she doesn't have. All right. So let's take a look. So obviously, for the first one's pretty simple if you get this formula down, which should be oh, they're using K for lead. Interesting. Okay, so pretend that's K. So the other one is, let's write this where we pretend we need to find our minimum and maximum carrots. So let's pretend that we do not have any leeks. So that means our carrot maximum is 10. All right. So carrot maximum is 10. And the next one, let's pretend we don't have any carrots. So 2 leeks is less than or equal to 10. That means the leeks that we're going to have is going to be less than or equal to 5. So these are our minimum, our maximum number of carrots we can get based off of the numbers. So first of all, we're going to shade down because she can't spend money she doesn't have. If she starts spending money here, like that's wrong. So we know it's one of these two. Now, here's the problem. We need to know what we're talking about. So if we're talking about carrots, carrots can go all the way up to 10. So this looks right. If we have carrots here and leeks here, that's right. We can't have 10 leeks. We can only have 5. So this is our only option. So both of these, if they would have switched the C and the K, this could have worked. But because they didn't, and then we're talking about leets here, so they basically want leets to be our Y value. And I should have read this because right here it even says K represents leets. So those should be our two answers. Cool. Moving on. So real world limitations. So let me get rid of this. Oh, it's Alt Z. Alt. That's easy to do. I'm going to try to memorize these. Hopefully, by the end, I'm just going to be able to do this super fast. All right, so real world scenarios. So these are known as invalid options because you can't have negative lawns. You can't mow negative lawns. So that's invalid. This one's invalid because you can't trim negative hedges. Basically, trimming negative hedges is people paying you for hedges you don't trim. You're just charging people for nothing. And that doesn't really work out that well. And then this one, so in general domain and range, so basically you can't, in the real world, you can't have, so that's why this is called real world limitations. You can't have negative hedges. Sometimes you can have negative stuff, but in this case, can't, like for example, if something's happening over and over, like if this was time and it's been happening for a while, but you started keeping track of it later, you technically can have negative time. But if you start doing this It's complicated. For the most part, just think of it this way: negatives are usually something that's invalid. All right. So here's our graph. So remember what I said: the maximum number of y. So the maximum number of y. Let's see if my theory works. I mean, I know it does, but just to show you guys. So the maximum number of y, we're going to pretend we don't have any x. So in this case, x represents, where is it? I'm going to actually circle. Oh, you guys actually have highlighter tools. I've been using these, but you guys can use your highlighter tools here. So x is going to represent number of wallets sold. I'm going to highlight that. And then y is going to represent number of hats sold. I'm going to use different colors for that. So our x is our number of hats. So hold on. So we want to do hats. So they're kind of tricking you here because they flip-flop these around. So hats is this one. And oh wait, no, they didn't flip-flop. That was my bad. Remove that highlight. So wallets is 20. And hats are 15. So that's why hats are y, so that's why it's 15 with the y and that. Remember, it's not saying that y is 15. We're not saying we sold 15 hats. We're saying $15 times the number of hats. All right, so let's see here. So valid solution or invalid solution. So we're going to plug this in here. So 2020. So if we go to 20, we go to 20, that one's good. So if we go to 15 and 22.5, all right then, and 22.5, that one's definitely in there. -4, and that's an invalid solution. You can't sell negative, what's X again? You can't sell negative wallets. That's totally invalid. 32 and 12. So if we're at 32, anything at 32 should work except for the invalid solution. So that's good to go. This one's invalid because you can't sell negatives. I have a feeling they're just testing us on knowing our valid's invalid because we're at 6, somewhere around here, definitely in there. So it was literally testing our knowledge about positives and negatives. So there we go. Incorrect. Is there something here that's not working? How is that incorrect? 20 and 20, 20 and 20, totally works. 15, so 15 and 22.5, that totally works. I don't know what they're talking about. We can't sell negative hats, so that automatically doesn't work. -4 and 40. I really hope they're not saying that it works. You can't have negatives. All right. So maybe they're just saying if it works or not. That's just weird to me. 32 and 12, so that's good. 36 and -8. 36 and -8. And it would work technically if that's what they're doing. 6 and 36, that would work. I just you can't sell a fraction of a wallet. That's what's happening. It's invalid because you can't sell a fraction of a wallet. That was my bad. You can't sell a fraction of a wallet. I was like, what? We totally went over this. So also keep track of what our variables are. Because our variable was a wallet, we can't sell a fraction of it. So we can't sell fractions of stuff. All right, so let's get going with this. So this is saying, Karen. So Karen spending money on apples. So let's kind of start highlighting it. So apples cost this much. So that's going to be my yellow. And then bananas. You know what? Let me switch it up because I want bananas to be yellow. Apples, we'll have green apples, and yellow bananas. Let's go with that. All right. And then Karen has that much to spend. So obviously she can't spend more than that. She can't spend more than her budget. So her budget, she has to have spent less than or equal to $20.50. And we're going to assume that our green here, our apples, 1.5. I'm going to call that X. And we're going to add that to 50 cents a pound for bananas. Cents a pound for bananas. All right, let's type this in. All right, so we're going to do 1.50 times X. And you know what? I should definitely check to see if they labeled it both amounts, write it as that approximately. So they don't even tell us which symbol to use. All right, and then we're going to do plus 0.50, and we're going to say Y for bananas, and we have to have less than or equal to 20.50. I was really worried that they were going to get picky on which ones I was using. I don't know if this would work otherwise, but let's keep going. So, and erasing it is Alt E. Oh, that makes sense. Alt E would erase everything. Alt E would be eraser. Alt Z is erase everything. Alt Z. That doesn't appear to be working that well. All right, whatever. Still working out the kinks, apparently. All right, so let's take a look at our summary. What did we learn today? So we learned graphing boundary lines. So the boundary lines is whether it has, so if it's a dashed line, there's no greater than or equal to, there's no or equal to sign. If it's a solid line, it has that or equal to. It's true if it's where it's shaded. So remember, if we're shading less than, it's below the line. If we're shading greater than, it's above the line. Remember our model. So obviously, if it's a budget, we can't spend more than that. If there's a weight limitation, there can't be more than that. I honestly, oh, they're talking about the keywords. So study your keywords for the test. And for this realistic limitations, just remember you can't really do negative numbers, you can't do fractions or decimals, and numbers that are too big or small. I'm guessing that's just if it goes in the line or not. All right. So I'll have this posted for you guys. I'm thinking about doing a Kahoot on Monday for you guys. So I'll try to create a Kahoot based off of the questions that I asked, or the questions in the study guide. All right, so let me turn this off.